Thanks for the introduction, Reed. Glad to see everyone here today, and thanks for everyone for coming. So welcome to the panel. The panel is titled AI Oh My, the Value and Limitations of Machine Learning for Your Startup. And thanks again for everyone for being here today. So to get started, I'll introduce myself. My name is Yasha Ektafai, and I'm a PhD student at Harvard Medical School. And I study machine learning in medicine, working with whole genome sequences and infectious disease, and trying to use machine learning to predict various phenotypes from that data. And on our panel today, we have Rich Palmer, an AI investor and entrepreneur, Ezra Friedman, the VP of Data Science at Klaviyo, Michael Schulman, the head of machine learning at Kensho, and Daria Dalal, senior AI research scientist at Posh Technologies. And thank you to our panelists for taking the time out of their days to be here today. And so as Reed mentioned, the way this panel will work is the first 45 minutes or so will be me asking the panelists some pre-prepared questions. And then the last 15 minutes will be audience Q&A. So if any audience members have any questions, just feel free to drop those questions in the window, and then I'll ask the panelists those questions. And with that, we will get started. So the first question we have is, what in your mind constitutes a good ML AI solvable problem? And I'll start off by giving this question to Michael.
Thanks, and hi everyone. It's great to be here. I would start by saying that a good AI problem to solve starts by being a good problem to solve. It's got to be an important problem to solve, or else don't think that this magical toolbox called AI or machine learning is gonna find you much luck. And something I think that I like to keep in mind and tell people to keep in mind when they're looking for the right problems is just assume any problem is solvable with machine learning. That will put you in the mindset of picking a problem that's actually going to be impactful. And then I'll also typically caveat it with, but also assume that it's only going to be solvable to like 95% human performance. And I know that that's not mathematically true. It's just a nice thing to keep in mind. So if you're looking for a problem that is useful to solve, but that the solution that's only 95% as good as you is going to be really impactful. And so that's a great place to start. I think the other things that I tell people to look for, again, these are just rules of thumb. These aren't kind of hard and fast rules to live by. Is it should be things that are, let's say, relatively easy for people to do. So a good rule of thumb that people throw around is it should take a human sort of 2 to 5 seconds to solve the problem that you're doing. I can tell you in my line of work, we end up solving a lot of automation type tasks with machine learning. And so if you can't specify the problem well enough so that a new person that you come to can't solve the problem in 2 to 5 seconds, you're probably solving the wrong problem.
Very interesting perspective. Thanks, Michael. And do you want to add on to that, Ezra? Do you have any thoughts about what's a good problem?
Yeah, actually, first, Michael, I thought that was interesting. But can you sort of explain that last bit? So the idea being, this problem should be solvable by a human relatively easily. Is that what you're saying?
Sure. Yeah. I think it's again, it's not a hard and fast rule, but I would say the longer version of assume any problem is solvable with machine learning is assuming you can specify it well enough. And one way we like to think about specifying problems is by collecting data. But before you do that, if you can't specify the problem well enough so that somebody who isn't really well steeped in the problem can come and understand the problem and, let's say, label a training example in 2 to 5 seconds, then you probably haven't thought through the problem in enough detail where a machine learning model is going to be able to do the same thing. And so that's kind of what I mean by 2 to 5 seconds.
Yeah, that's very interesting. So I like this. Right, every problem can be solved with AI, or assume that the problem can be solved with AI. Right. One sort of other point that we sometimes come across in our work at Klaviyo is like, sometimes the problem can also be solved through more traditional statistical methods and not AI. So it's a balance of I think the way we do it is we generally start from a simpler model and, like a regression, or, really just try to approach things from the easiest way possible. And then when we find that the results that we're looking for, we're not getting, then we'll start to look at machine learning and AI. And I think, I think one benefit for us at Klaviyo doing that, and we have tens of thousands of customers, each with their own data. And so, like when we want to build a model, say, for our customers, it really means building a lot of models. So, we can save a lot on things like compute. But, I think we can also, sometimes end up with a more explainable solution. So I believe there is absolutely a place for AI and machine learning, but just presenting sort of the counterpoint that it's not the solution to every problem.
Yeah, mind if I also jump in on that? So I was gonna say, I also agree with what Esther said. I think oftentimes we try to throw shiny models at problems that perhaps don't need to be solved by shiny models. So if you could get away with a set of business rules, if you could get away with having a logical kind of set of decision boundaries, oftentimes those go really far. And so oftentimes, if you're thinking about the time trade-off, and the question is the AI model worth it? I think the two things you want to consider is if like 80 to 90% of your use cases can be explained by a set of rules, like a bunch of if-else statements or whatever it is, then the machine learning solution is probably not the right solution. But if you have a problem where it turns out, no matter how many rules you write, you can't capture all the use cases, or in the situation where you have a continuous stream of data coming in, which is going to be annotated. And so, it turns out you can't keep up with the new decisions that you need to be making, then like a machine learning solution makes a lot more sense. And so just keep that in mind, because it's always going to be a time trade-off. And so, you're going to sacrifice oftentimes precision and recall if you start moving towards a machine learning solution if you don't have enough data. And so keep that in mind as well.
Can I actually ask a follow-up? I don't know if I'm going off script or not, but to Ezra and Daria, are there things that you notice about the problems that are just not amenable to the simpler solutions? Like, are there common themes to look out for where somebody should be saying, okay, I gave it my best try, and I need to try something. This is an important enough problem where it's worth it to do the crazy thing and try some giant model.
I think it's a great question. I had one example that comes to mind. Right now we have a small team working on a project around text generation, right? And that's an example of something I struggle to imagine a rules-based model or similar, doing the kinds of things we're doing. I feel like many problems in the NLP space, which sort of, I think, a lot of the stuff that's being built now does sort of feel magical. And so that would be one broad category. I'm not answering your question in terms of like, when you look at a specific problem, making that call, but that's something that comes to mind.
Yeah. Also, I think about, how specific is your domain and how much can you get away with, using a pre-trained model or a model that, has a significant amount of data in your space that's going to be valuable. So for those who are unfamiliar, a large trend that you'll see in machine learning is the idea that you can basically, instead of training a model from scratch on your data, you could pre-train a model with a lot of data. So this is a thing that you see a lot in NLP models, where you'll take a model and you train it basically on all the internet and like all the books ever written. And then these models have a really good understanding of language, they have a really good understanding of how words are used in different contexts, usually English, though you'll see a lot more multilingual models coming up as well. And so it turns out these are pretty useful for general purpose things, everything from like sentiment analysis to intake classification, things like that. But what ends up happening is that, if it turns out you take one of these general models and you apply it to something very specific, let's say like healthcare language, or in our case, financial language, you'll see that things sometimes will fall apart. And that's where you kind of, need to go back and say, either need to, fine tune that model to make it useful for our use case, or I need to probably build something from scratch because it turns out my foundational language is significantly different, distinct enough from what the general model has been trained on, or I don't have enough examples for me to train a model from scratch. So I need to figure out what a good kind of machine learning solution that meets in the middle might be. So that might be another example where you might say, okay, my standard approach, the probabilistic approach, is not working, and my out of the box approach might not be working, and so I need to actually now look at building a custom solution.
Yeah, Michael, I think that's a great question. And just like add on my own thoughts to that. In my research in biology and medicine, often the problem is that there's like a gap in knowledge. So let's say you have like a genomic sequence and you're wondering what is the mutations that cause a specific phenotype? Like what's the mutation that gives someone cancer versus gives someone no cancer? And doctors don't know. Otherwise, if they knew, they would use that information, right? So when there's a gap of knowledge, the hope is that with enough data that the model could potentially learn something that in the field is currently unknown. And I think a perfect example of that is AlphaFold from DeepMind that came out like a month ago, where they solved protein folding problem. They solved the problem that biologists weren't able to do. And that gap in knowledge and identifying those gap in knowledge in the field, and then as you mentioned, framing the problem correctly such that it can be solved with machine learning is, I think, key in order to use machine learning effectively in these domains. So, but yeah, great question, Michael. And I guess to go off of that, there's this whole idea in machine learning and AI about the problem of like data engineering. Often, especially like when you're building a model, you find yourself, you spend 90% of the time trying to get the data set right, and then only like 10% actually working on the model. And so I was wondering, how do you guys feel about that? And for a startup that's looking to work in like with machine learning, how should they approach this problem about data engineering versus model development? And I guess I can give this to Rich if you want to add your thoughts on this.
Sounds good. Yeah, thank you. And first off, Yasha, this is just talking now, so I'll give you a little context of why I'll say what I'm going to say for the rest of this talk. First, I started a company that did NLP and deep learning for social good space. So when we talk about biases and things like that, I think I'll have some strong opinions there. But I've also now seen a lot of early and growth stage work on the other side. We had a successful exit. So seeing startups wrangle these questions and deal with them and fail and succeed has been quite interesting, and it changes. And the thing that's really what I see is it's a difficult question to ask broadly, right? It's a kind of, if you're an early stage company, if you're a growth stage company, or like some of my counterparts here, and myself included, we have lots and lots of money and lots of really interesting, super smart people behind us who can think deeply about just this problem. A lot of times when you're early stage, you don't have a choice of an or, it's like an and you have to sort of solve all this, get it out in time to beat whatever you think the market is going to need, and then realize you're going to mess it up anyway. So you have to iterate very, very quickly and go back and forth and back and forth. The standard sort of thinking is that 90%, 95% of AI is data engineering. I would back that up. But I would also argue that a lot of early stage companies can't afford people that can do anything with that data anyway. So one of the first things is to just find the way to amass data that matters. And like everybody was saying, we said things like, what's important? What are the trade-offs? What's worth it? One thing, and I'll put the mic down in 1 second. You all are here with us for like 45 more minutes. If you want a couple more hours, there's a really good book called Prediction Machines, which basically takes all the stuff we're talking. I have 3 books. I'll probably throw, these aren't my books. These are other people's books. It basically looks at AI through the lens of an economist. How do we actually manage those trade-offs? How do we decide what to automate, what not to automate, and all that kind of stuff? This can take you further from our little kickstart here. So thank you. Appreciate this.
Thanks for that input, Rich. Yeah, that's definitely a very interesting perspective. And I guess, yeah, for a startup that's, just trying to get their feet off the ground, they sort of have to like solve all these problems at the same time. But I can imagine that could be like very overwhelming for a startup. And then we were talking about this idea of like, how much time does it take to implement the AI? Because when you talk about runtime for a piece of code, it's not just how fast the code runs, it's how long it takes you to write that piece of code. And I guess that's something a startup with the limited time and resources has to really think critically about. And I just want to pass this thought and question to Michael and see if you had any thoughts about this.
Yeah, I do. Maybe before I answer, I'll also just second what Rich said. I try to stay somewhat connected because of who our clients are to the hedge fund world. And I hear a lot of people kind of going to hedge funds to build up their giant machine learning effort, and they're going to swing for the fences. And of course, whoever does that gets there and realizes that they spend the first 2 years getting the data in order before they think about machine learning. So I think that really rings true in lots of domains. I'll be an optimist here though, and I'll say it's actually good for a really young company that it's mostly data engineering. You wouldn't want it to be that there's going to have to be some like really deep academic level breakthrough in machine learning to enable what you're doing, because you're a tiny startup. You're not a giant research university or a giant industrial lab. Your ability to do that stuff is not zero, but it's certainly less than everybody else. And as a small company, your ability to move fast and iterate and find the right problem to solve, that's your edge. And so it's a really good thing that if it's 90 or 95%, who cares? It's a really good thing that it's mostly not machine learning.
Yeah, that makes a lot of sense, I guess. Yeah, I guess it is a good thing, because also by looking at the data, you also have to think about the problem itself, because the kind of data that you collect shapes very nicely of the machine learning problem. So often by the time you collect the data, it's like, oh, like it's pretty obvious how you're going to use machine learning because you've thought so deeply about it to get the right data. Yeah, super interesting thought.
And Yasha, can I add one more sort of point here?
Yeah, go ahead. Yeah.
It's also a little, I hate to use this word, cross-functional. I'll explain what I mean there. You don't get that data without usually receiving it from a customer, receiving it from a user. And you have to ask permission. You have to do something that matters. You have to establish relationships. You have to do all these kinds of things. So that's really interesting. The data part of this early stage is maybe just a synonym for building relationships, solving things people want solved, and gaining trust. And then we can do all the cool stuff. But maybe it's get the data, build the trust, apply off-the-shelf models, and then build up more sophisticated, interesting, fun stuff.
Yeah, and I'll add to that as well. We started off as a pretty small company. It was 2 students out of MIT, and initially, even though they're both students who were out of the MIT AI lab, they were using off-the-shelf models because the idea was that we just want to prove that the product was a good idea for the market, right? And so that was a starting point. The other thing I'll add is that on the data side, it's also really interesting. 2 things. One is you should probably treat models as a commodity. I mean, given the way in which research is shared today anyway, like every model that's out there is accessible to all your competitors as well, right? So if you're spending all your time, chances are that all the things that you have access to, everyone else probably has access to as well in terms of the model development. And so really your competitive edge is the data that you procure. And so if you have the ability to either sit on top of a data source that no one has access to, or you have the ability to curate that early on with building just a good product, that's important. And so the thing that we focused a lot on was how do we build annotation into our product as part of the user experience that gets us annotations for both free, but also makes it good customer experience. And so if you have an opportunity to build tracking to your product, things like asking for feedback from the customer, is this a good prediction, or is this a good suggestion or not? So thumbs up or thumbs down, or did we or things that are implicit. So for example, we'll track sentiment at the end of our conversations with the sentiment model, and for all the conversations that we do poorly on, we raise that for further annotation, and we use that as an opportunity to source areas where we might want to go back and start looking at why those use cases our model failed, and then build annotations accordingly. And so if you can build annotation into the product, it'll set you up for the long run, because early on you just want to get something that people like to use, and you have a nice kind of flywheel for generating things that will be useful down the line. And then once your organization is mature enough, you can actually start hiring out a data science team or a machine learning team and build actually really interesting solutions and building new solutions on top of that.
Yeah, no, I really like how both Rich and Daria said, right, like the data engineering, it's not like sometimes when I hear that whole, 95% is data engineering and 5% is working with these off-the-shelf models. Like it's not I don't know, it's not really, in my experience, it's not really true. And, you know, it also sort of cheapens the work of, you know, how do you use them? How do you select the model? How do you use it? How do you tune it? How do you deploy it? Like, I mean, there's so many things that go into, in my experience, right, building something that's actually going to provide value. But I like in general, I don't love this 95-5 kind of split thing, but right, when you think about, it's not just cleaning the data, it's right, deciding what data you need, getting permission to use the data, like labeling, determining what data you don't need, right? There's a lot more to that, like, and maybe that's what data engineering is, but right, I'd say in my experience, like, just sort of clean, like once you have access to the data, whatever, and cleaning it, right, we all know that's not tremendously difficult. There's a lot more to getting to a solution that's providing value.
Maybe a slightly, I agree with that 100%, Ezra. Maybe a slightly better way to say that, you know, the point that's trying to get made is, if you're spending more than 5% of your time trying to come up with some new model architecture, you're probably doing something wrong.
You're saying because this is a field where things are published and where, right. Yeah, no, I think that's a really interesting spin on it.
Yeah, I totally agree. It sounds like data engineering and data mining is sort of like vitamins for like an early startup, because it forces a startup to like consider many things, like forming connections with their customers, thinking about the problem, thinking about where they want to go. So I guess often there may be a negative connotation with, oh, you know, like data, gathering data. But in this case, it seems it's important for an early startup, because in gathering that data, they consider these things that will later on be important for their successful growth and hopeful success. And to move on, Ezra, you were starting to touch on this a little bit, but I guess the next question we have is, how do you recommend like a young company to set up their AI ML infrastructure in the early stage? Like, do you just start out with a bunch of Jupyter notebooks and random scripts like in some cluster somewhere, or do you like work to like institutionalize everything and make sure it's scalable early on? I was wondering if you had any thoughts on that.
Yeah, no, right. It's interesting spin, you know, on this, thinking about it for a startup. I mean, I think there are some technologies now that, like something like Docker, I think is so integral to like building something that's going to end up in production. So like, right, there's some things I would recommend people, or, you know, sometimes, right, I think there's this idea that data scientists are, you know, they maybe, right, work exclusively in Jupyter, and right, I've interviewed people, and the question I often ask is like, you know, sort of tell me about your relationship to source control. And because like I come from like more software engineering world, and it's like so critical to how I do things. So like, right, I think that's a practice that you should from the very start be following. And then there's like so many, like the tooling, and I use AWS. I'm sure it exists in the other cloud providers, but right, there's a lot of easy to use tooling around, you know, specifically if you're starting with right, using like writing code in source control, deploying it with Docker. I think that's a good sort of table stake start. Curious what people think there.
Yeah. So, you know, it really depends on kind of what you're trying to do. So if you're using a third-party solution, you know, then usually they take care of hosting for you, and what you're really caring about is getting the right data, and you're focusing on like the data engineering and the annotation pipeline. If you're going to be, you know, building a custom model, I think, you know, there's a couple things tactically you want to do first. One is just choose where you're going to deploy your models. So like, you know, there's like 3 main providers that people will use. It's either AWS, GCP, Google Cloud Compute, or Azure. Most of the other services that, you know, provide hosting are usually built on these services. So chances are, you know, if you just go to the source, it's much easier. And we'll choose whatever is, you know, makes sense. For us, you know, we started off at AWS and then moved to GCP just because it was much easier for us to work with in terms of both transparency of pricing, but also like the ecosystem for GCP was just nicer for some of the other features that we had. And then secondarily, one of the things I wish we hadn't done in the past for both my startups was spending a lot of time building custom deployment frameworks. Honestly, like there's great tools that exist out there, both open source and paid. Just use something out there. Like it's super simple. Most of these tools solve the problem that you were mentioning above, which is like, you might have data scientists who work in Jupyter notebooks or who might work in like, some weird kind of thing. And so a lot of these frameworks keep that in mind. They'll make it easy for you to take a Jupyter notebook and deploy it, or, manage your experiments and then, hit a one-click deploy. So as long as you have your end thing set up where, wherever the model is going to be deployed to, the, these frameworks like MLflow or Bento ML or, any of these other things, kind of just manage orchestration for you. And honestly, they do a much better job than anything you're going to build in-house anyway. So like save yourself time and just use the off-the-shelf tools there. And then, kind of just to make sure that you have your kind of different pieces put together. So you have your, your data source, you have your orchestration layer, and then you have wherever your deployment and scaling things on the back end. And just as long as those three things are connected, life will be easier for you.
Yeah, that makes sense. So it sounds like an early stage like startup shouldn't really be concerned about the problem of infrastructure, because there's so many tools out there now to make that easier for them and to help the startup focus on what's important, which is getting the data and the other things that we've described earlier. And I guess the next question I want to ask to Rich is the idea of like the labor market right now. So as you know, like there are so many people who can put on their resume that I know how to do machine learning and AI. And then when it comes down to it, all they know is how to like import Keras or something like that, some TensorFlow, and they don't actually like understand. But on the other end, there's a lot of like PhDs and like computer science coming out of the labor market. And how do you choose like who to hire and for your early startup in order to make sure that you're successful? How do you navigate the saturated market?
It's a good question. Again, it's weird. It's like depending on which stage you're at, you have to kind of make choices. Like a lot of folks that I hired later on were much more expensive. I could never afford them, nor would they really want to solve some of these problems. They were more interested in model development. They didn't want to go with me to the customer and talk about how we were going to solve something 2 years in the future. So can I have your data now so we can mess around with it for a bit? So some of these like really difficult problems. A couple of things, like very practical advice that I sort of give to folks is try to get as specific as possible. So for example, I'm going to give away a little bit of a playbook here, but we talked a little bit about NLP here. Having an AI background doesn't mean you have a great NLP background. But all of a sudden, when you look at certain schools, so Brandeis is a good one up here that has a dedicated computational linguistics program. Everybody's looking over the river at Harvard and MIT, but they forget about some of these specialized programs, right? And so thinking about where that's happening, because one thing I love is those are usually smaller schools that you still have access to the professors that are there, and it's another talent siphon, except for the 100-something people that are watching this now who are all going to start doing this, right? The other is don't necessarily think that you have to get somebody right out of the gate that is going to solve some problems. You got to be comfortable, especially early and sometimes growth stage startups have to look at this sort of rough edge and see if it'll turn into a circle, So for example, one of the people that I hired early on was linguistics undergrad, comp sci masters. So those separately combine to a lot of NLP related skill sets. We just needed some time to work together to sort of basically say, here's your 3-6 month plan. We're going to go through textbooks together. You can do whatever. I'm going to pay for it as the founder because you're training on my job. You could leave because you could. So it's a risk I have to take. But showing that kind of sort of professional development and getting people to that, sometimes you have to do it. And just super be careful. Oh my God, I'm probably gonna get in trouble for this. If they're like, oh yeah, I took Andrew Ng's like machine learning course. I know machine learning. It's like, yeah. Only about 1% of people or something graduate that. And even those folks, I'm not sure if you would hire them. So mic drop.
Yeah, really interesting perspective, Rich. I definitely agree that depending on what stage you are, and what your needs is as an early startup, that question could have different answers for different people. I wanted to then pass this question on to Michael and see if you had any thoughts about the whole hiring process and the labor market?
Yeah, I do. I would also definitely agree with what Rich said. I think for us, the real hard work was figuring out exactly what are you looking for, and that obviously changes as you go. And then the easy part is actually figuring out how to ask the right questions. At least that's my experience. It's much harder to figure out what you were looking for. And I think the market is like pretty saturated, but like any market, there's a pretty wide spectrum. And there's a lot of differentiation there. And so, to figure out what your niche is, if you're doing NLP, maybe it's Brandeis. If you're doing, self-driving cars, maybe it's something else. I know nothing about self-driving cars, but I think that, kind of trying to figure out where your edge can be in going after the right portion of the market is really, really important. I can tell you, yeah, at an early stage company, you're probably looking for a generalist, and it may not be appropriate to have a PhD in computer science. And especially kind of going back to what we said earlier, that most of the early stage stuff is not coming up with some new model architecture or probably even model development. That's probably not even the right skill set. So I don't think there's a surefire way to figure out what you're looking for, but I would just tell you, if you're early, spend a tremendous amount of time trying to put down on paper, these are the things that I need, and these are the things that are going to make someone successful in a job.
One thing I'll add there, right, Klaviyo, and who knows what a startup is today, but we're approaching 1,000 people. But when I joined, we were much smaller. And when I joined, we didn't have a dedicated data science team, and I actually joined with someone I've worked with for a long time. We joined together to build this team. So we were sort of a startup within a startup when we started. And right, it's been interesting to see sort of the profiles of people we've been looking for over the 3 years that I've been at Klaviyo. So in the beginning it was, we wanted people who more probably had a profile of someone who might work at a startup and start a company. And we have interviews for we break it up into 3 pieces, but sort of the math stats interview, the software engineering interview, because at the end of the day, we're a software company and we have to build something that gets into users' hands. But then we also do a product management interview and sort of talk, how do you think about if the customer has these requirements, how would you approach, a project, and what questions would you ask, and what features would you design in? So, right, we were looking, we ended up sort of calling it full stack data science. And part of the reason was we just want to make sure we're level setting with the person who's going to be joining. Right, if you're looking for a position where you're studying models all the time, and that's 100% of what you're doing, then this isn't the job for you, at least at this time. But right, I think now, as our startup within the startup is becoming more just sort of part of the company and it's bigger, right, we are looking at people with much more sort of specific skill sets. So I think it's gonna vary, with the growth and needs of the company over time.
Yeah, definitely very interesting perspective. When I hear the market is saturated, I always think it's a negative thing, but for an early startup, it may actually be something positive, because it means there's something for everyone there. And depending on your needs, you'll probably be able to find someone who can fit those needs. And so then it's up to the startup to be able to express those needs and figure out what they need out of their people, be it a custom model or someone more generalist, and then go out and find those people. And then I guess for our next question, and I'd like everyone to try to answer this, perhaps the most important question, what are some common pitfalls you see in, because it sounds like a lot of people here have experience with multiple companies who've tried to use machine learning in their startups. So what are some common pitfalls you see in early stage startups that try to use machine learning, and any advice that you would have to avoid those pitfalls, and anything else like that? And I guess we can start with Ezra with this one.
Can you start with someone else? I want to think about it for a second.
All right, no worries. What about Rich? Do you have anything to say?
Sure, a couple things. So there's pitfalls, and then there's sort of bottleneck for adoption, right? Which I think they're could be connected, but I'll answer them a little bit separately, right? One of the pitfalls we already talked about, and so it's maybe worth remembering here. AI can solve many things. Machine learning can solve many things. Oftentimes, it's not where you necessarily need to start. We talked about things like rules engines and certain stuff like that, off-the-shelf models. So there's a Q&A question here. I'm not familiar with like the big catalogs of this stuff, but I am personally very curious about low and no code AI stuff like obvious.ai and certain things like that. I've not had personal experience. I hope it will work. I hope the hype keeps that kind of stuff going to democratize this for everybody so we can use it no matter what for every problem. But again, the big pitfall is that trade-off and that concept that ML AI is not necessarily going to be the thing that you should solve. The other thing that is really important, and a pitfall I've seen in every company, and this is probably true of software development in general, everything takes longer than you thought it was going to take. And so if you are a non-technical person listening to this audience and your technical counterpart holds all the information and all the knowledge about this AI stuff, work with them to make sure that they're thinking critically about the breakout points, the checkpoints, and all that kind of stuff. Because especially if we get bogged down in feature tuning, or if we get bogged down in all of a sudden some of the data is not right, or the model doesn't get deployed correctly, or the users aren't using it fast enough, every single one of those slows down time to value, which is the killer for startups. And the other thing about adoption, and I'm sure we'll talk about it a little bit more later, but a lot of the job of data science teams, software in general, is translating for your non-technical counterparts. The marketing folks, the sales folks, the HR folks, your leadership, whoever, right? So the biggest barrier to adoption, I think, is not finding a common language so everybody understands. On both sides, you're not alone in those conversations. So one of the hiring things I do, if I know someone's super smart, I'll ask them to explain something to me like I'm grandma or like I'm 5 years old. And it'll be something ridiculously complicated. And their job is, they know that it's like within 3 minutes or less, they have to narrow it down so we can get sort of like the elevator conversation on exactly how reinforcement learning works and how you would deploy it. Okay, that's kind of tough to do if you're all in your head, So being able to translate that adoption concept, I see that being a huge bottleneck to adoption. Also because the bigger you get, the more siloed data gets. And if you need to go into another department to get some of that data back and you can't explain why you need it and why it's going to benefit them, you're going to fail. I see that over and over again in the biggest companies in the world that I've worked with. So I hope that's helpful.
I'll also add to this. I think oftentimes expectation management is really important. So people like to think that building machine learning models and AI models is similar to just like general software engineering. And it's not, for a couple of reasons. One, outcomes are not like deterministic. So because most of the methodologies that you use will rely on probabilistic outcomes, what ends up happening is that you can't guarantee the system's gonna make the predictions that you want it to make. And so when things break in really weird ways, you provide a weird input, or you get predictions you're not expecting, it becomes really hard to kind of debug that and understand why it's doing that, right? And especially if you have a model in production that you have you're continually retraining and you're providing new examples, you'll find that there might be like drifts in terms of what gets predicted and how it gets predicted. And so if you're trying to go backwards, right, and try to figure out why it did that, that becomes really difficult. And oftentimes when you're trying to build good software and have a good product experience for your customers, right, you don't want to have that variation and you don't want to have that kind of that drift. And so you need to either put up guardrails to ensure that early on you can control the experience in a way in which things appear the way they do, or you have some sort of expectation management where you may surface the predictions or whatever the features are that you're surfacing from the models in an environment where the customer is aware that there might be some error around it, right? And so I think one of the that's one of the key things to keep in mind. And then the second thing is when you're thinking about kind of deploying a machine learning model, you want to make sure that you have tested out completely in a way in which you could kind of control for some of those weird edge cases you might get. And so when the model makes a mistake, the cost of making a mistake is not high. So like we talk about, type 1 and type 2 errors, and really, it's okay to have false positives in a way in which, like, if your models, it's okay to have false positives if the outcomes of your models are not life and death for somebody. If they are, then that becomes really bad, right? So if you have let's say you built an app that helps make suggestions for writing an email or something like that, and you come up with like just a really weird kind of suggestion, the customer might look at it funny and think, oh, okay, this is kind of odd, and that's okay. But if it's like, like Joshua, if you're working in like medical domain and you all of a sudden say this person has cancer when they don't, that's bad. You don't want to do that, right? And so, making sure that you understand where your models are being used, and making sure the expectations are there that there's going to be this wide range of outcomes sometimes, and you can't really control it, is also really important. And sometimes startups will struggle controlling customer experience because customer might be like, customer might have these unrealistic expectations that the model's AI, so obviously it's intelligent, it should be able to do all these things. And it turns out, like, if it makes mistakes that seem really dumb, there's going to be a lot of frustration. And so you want to kind of think about that from both a product point of view as well as kind of a technical point of view.
I know I turned down my chance, but I'll take it back. But no, I think that's really interesting around sort of explainability, and right, the fact is this generally these are like non-deterministic models, and you can't totally anticipate exactly what's going to come out of it. One example that came to mind early on in my time at Klaviyo was talking to a customer who was using, we have like some collaborative filtering algorithms for like product recommendations, the sort of, I bought this and that, you bought that and the other, I should buy the other product. And the customer was sort of like coming to me saying, right, these recommendations make no sense. Why would you be recommending that product to this person? The actual details are kind of funny, but I'll hold them back for this wide audience. But and I proceeded to like sort of go into the data and say, well, actually, like it does kind of make sense because this person did buy these two things and this person bought those two things, and right, it was still very hard for her to, right, she's a marketer, and it's very possible her instinct is totally correct, and right, we encourage our customers to A/B test, everything. So right, like curate your own recommendations, use our automated recommendations, but right, I think that's another problem is when the customer sort of is not happy with the recommendation, and it's difficult for you to sort of explain why it happened, and you just sort of, it's a tough problem as a software provider to manage that.
I guess I'll go last then. I would say that I would say maybe two common pitfalls and then one other thing. So I think the first is that people will forget to avoid complexity. I think good software engineers are amazing at avoiding complexity, and I really like to watch great software engineers do that. And machine learning practitioners, we forget that, and we try to make things really complicated. That's never a good idea. I think related is, I think a common pitfall is people getting sucked into what the kind of sexy notion of what they think doing machine learning means, and forgetting that this isn't sexy work. It's fun. It's not sexy, but you have to do the right stuff. So don't grid search your parameters. Don't figure out the right architecture. Do the stuff that's going to end up moving the needle. And then I want to maybe give a slightly contrary opinion that, and I work in different domains, so this may only apply to the types of problems that we solve. But I've seen I certainly in the early days, we would get mired in these questions of interpretability from clients. And one way is to try to interpret your models and to try to shine as much light on them as you can, and set expectations that these ultimately are not going to be totally understandable because they're statistical in nature. But the other would be to find problems that don't need interpretation. And if you can do that, you end up avoiding a fair amount of pain. I happen to work in domains where we can do that, which is nice. And not everyone has that luxury, but it's just something to keep in mind that if you're getting a ton of questions about interpretability, it's maybe a sign to think again about a different problem to solve.
I'd love for you to elaborate just on that, because you mentioned something about hedge funds, or like, is it because the performance of what it was trying to do generally can speak for itself, or the metrics are very clear?
Yeah, so it's actually both of those. If you can find a problem where the metrics that are completely, the performance of the problem is completely defined by some numerical metric, you just avoid having to explain things to people, and you say, the old way, does 0.7, and our new way does 0.9, and that really speaks for itself if you have that luxury. I think the other thing though is these questions of interpretability, they're not really asking how well the machine learning algorithm is doing. You're asking how well can you assign the intuition of the client onto the machine learning algorithm, and you're trying to remove the client from that, and so it's a little bit backward, and I understand that it's necessary in most cases because you need to get people comfortable with it, but that's not really what we're going for in the end.
If I can add one thing too, it's really interesting. We talk about customer happiness, removing the client in like a consumer product or like a B2B kind of product or something. You can't say like, oh, I'm going to take you away. So like the real strategy is putting them where they'll do the least harm. But like we talked about, helping with annotation, labeling data, and all that kind of stuff. If you can make it so that their expectation is the more they use it, the more forgiving they are, the more it's going to work 2 or 3 steps down the road, like you've won. That's like the holy grail. It was some of the early stuff that we had with like chatbots failing because they weren't so great in the beginning. They weren't great because no one would get past step 1. They just pick up the phone to call. So you never had this sort of like training loop to add the customer to this kind of thing. So I triple second this whole discussion here.
Yeah, Michael, that's such a great point. Like in my work, when I show a doctor like the output of our model and what it predicts, usually the doctor's like, we want it to be interpretable, but then they have their own biases as to like what they think the model should be doing. But that's not what the point is here. We're trying to like discover something new of the model, if that makes any sense. And I think in so many cases in machine learning, like the model that like does the best often does something that's totally not within intuition, something completely new, and that people initially are against. So it's how can we balance that? Because maybe this recommendation it made and the way it made it is something new and interesting, and the fact that it's not intuition is showing that we're learning something useful and definitely in the market and everything like that. And so before we move on, I just wanted to take the last few 10 minutes here to answer some of the audience questions. There's around like 4 of them, and just give a chance to everyone on the panel to answer these. So I guess I'll publish the first one here. Let's see what happens when I click publish. Okay, so the first question is by Keith here. So this is back to our whole discussion about these off-the-shelf models. So is there any resource or anything any of you have? So let's say you're a startup and you want to understand what's out there and what are the sorts of problems that you can already solve without having, dive into like 20 or so papers. Is there any resources any of you would recommend for this?
I could jump in here. So if you're working on NLP problems, I think there's been a lot of really interesting kind of work making a lot of these models accessible, especially with Hugging Face, which is a great company. Highly recommend them. So they are also, funny enough, a startup, but they've done a really good job of kind of making all these latest and greatest language models accessible to the public. And so they have the Hugging Face datasets library as well as the Hugging Face models repository, both of which, you could log on, you could go to their website, search up like any kind of problem that you have, like sentiment analysis or, translation from English to Spanish or whatever it is. And you'll find a model page that will pop up. You'll have like a little kind of cool little interactive where you like type in your inputs and see what comes out, and you can play with it. And then also just the API that they have is really easy to use. So they make it super easy to kind of take an off-the-shelf model like BERT or many of these cool new things like Roberta, Deberta, things like that. It's like usually 3 lines of three lines of code to kind of just get up and running with it. So on the NLP side of things, definitely recommend them a lot. I'm sure the other folks will have other resources for other domains.
Yeah, I can jump in. So one of the things that's interesting, right, is like there's like the joke that lots of good software engineers are not really good software engineers. They're really good Googlers, or they can hang out in Stack Overflow pretty well. And so one of the things that we used to do is sort of have this 3-part Venn diagram above our data science team's desks. One circle was, do we have the right data? The other circle was, do we have the right use case? The other circle is, do we have the right algorithm? If you can go between 2 of them, you can finish the sort of triangle. Like, I have this data, I have this use case, what's out there? What have other people tried? So then rather than working forward from a model, it's always okay, and there's no shame in it, working backwards from the data you do have and the problem you're trying to solve and see how other people have solved it, and then work forwards. Just want to give people some motivation there.
Yeah, I would also plug Hugging Face. I use it so much. It saves so much time, and Hugging Face does a great job of also showing you the paper. So if you look at the model and you're like, oh, I want to learn more, you can dive deeper, or if you just want to use it. And there's a reason why Hugging Face is so like everywhere right now, and that's because they do this job well. And I guess I'll move on to the questions just to make sure we answer them before our time is up here. Another question that we had is here, this idea of the fact that there's keeping with this whole concept of like off-the-shelf models, the fact that there's a bunch of off-the-shelf models, as we talked about earlier, this idea that like anyone could use them, right? So what is the thing that sets startups, how do you become competitive? And I guess, Daria, I think you mentioned something about the data sets and maybe sitting on a data set that other people don't have, or, being the first to mobilize the data set in a specific way. And just wanted to see if anyone else had any other thoughts or wanted to add to this.
I can jump in there. I would say it boils down to 2 things, which is data and your ability to frame the right problem to solve. And the only way you're going to find that is by iterating quickly, but it's just those 2 things, in my opinion.
Feels like we have some consensus there, right, Rich? And yeah, it definitely sounds like a great way to look at the problem.
And with my investor hat on, it's usually not the model that I'm most thinking of as the competitive barrier. There's so many other things that are more important. So I'll actually, if you come at me saying, oh, we've created this model and that's what our barrier is, I'll be like, well, that took a long time, I'm sure, and you're really smart. What else did you miss, So it actually opens up a whole slew of things you probably don't want me poking around at. Just to be honest, I'll give you my playbook.
Yeah, so we do conversational AI for community banks and credit unions, and so we definitely have some really, I think, cutting edge models that we use and kind of interesting applications. But honestly, the thing that's unreplicable about our problem space is really we've done a lot of legwork in working with external integration providers and digital banking providers, right? And so to be able to understand how to work with a bank's backend, which has a lot of old legacy code, and having the ability to get the right data that you need and the ability to make the right transactions on the customer's accounts is actually really non-trivial and takes a lot of time. And so building the chatbot oftentimes is the easier part of the problem, but building the additional functionality that requires us to kind of be able to make payments on behalf of the customer, or make really interesting features around managing their bank accounts and helping them ask questions about their bank accounts or schedule payments and things like that are really hard. And so if you're thinking about what's the technical edge, look for things that require one complex really technological solutions that are you had to either work with other people to build out your product, or you have to think about building actually significant engineering kind of portion to kind of solve that problem that isn't as easy as plugging and playing a an existing off-the-shelf model. And the second thing is, whatever your domain knowledge is, right? So like we have worked really closely in the financial space working with credit unions because we were incubated in a credit union credit union financial innovation lab for DCU. And so we got a really good kind of understanding of that space. And we're also a credit union service organization. So like we work really closely with them. And so building a good domain understanding makes it really hard. So there's like 50 chatbot companies, but the number of chatbot companies that could work within the space that we work in is actually very few. And so, as you kind of figure out what your niche is, and you want to make sure you rely on those connections and your knowledge to build out, your knowledge to navigate that space in a meaningful way. So, yeah.
Awesome. And I guess another question that we had that was also thumbs up is this idea of where does machine learning fit in marketing? This is an area I definitely don't have any exposure to. So if anyone else wants to answer this question, go for it.
I can give a stab. Oh, somebody's jumping in. Go for it.
Oh, no, right. So, Klaviyo, our software, it's marketing, automation, and analytics. So, it's interesting. Like, what's the first most promising area to try? I don't know. I guess one thing I'll take a little bit of a spin on that is just, A/B testing, right, is something like if you're thinking about, incorporating statistical models into your behaviors, right? Like we really do encourage our customers to A/B test. And if for people who maybe aren't familiar with that term, it's, it's running an experiment, and you have sort of a control and a test group, and you look at how, for example, if it's an email, let's say announcing a sale, does including a coupon code impact the behavior of the recipients of that email? The more of them return back and convert. So, right, I think in marketing, like sort of structuring your questions, and right, a lot of times it might be something about like return on ad spend. Like if I acquire a customer through a certain channel versus another channel, like how do those customers behave over time? And so, for example, maybe, through Facebook, it's like a very expensive cost to acquire the customer, but they turn out to, become my top performing customers. And maybe, through a Google ad, it's cheaper, but they're sort of like a dead end and they're not good leads. So, right, I guess having that testing mindset, and then when you start to incorporate things like a.k.a. models, like my example of the product recommendations, right, you have this structure to evaluate, are you getting benefit from this technology? And you can really quantify it.
If you want to go to the next question, you can. I was going to say quickly, I know there's also interest in like customization of text for marketing, and trying to figure out what is the right message for the customer you're trying to convert. And so I know Rob May, who was our previous founder and runs runs a VC as well, focusing on AI things. If you manage to create a product where you have information in a marketplace, like let's say Gumroad or Etsy, and you have the ability to maybe like A/B test where you can figure out messaging that works well for certain markets, and you can figure out how to translate those messages into kind of other products or other things that keep interested in that in a heartbeat. So if you have a way in which you can figure out how to automatically generate marketing materials using information that you have in a closed market, there's some really interesting kind of investment opportunities there for you guys.
A phrase I like using to tie that all together is personalization at scale. So when you think about like what your favorite word is in whatever language you speak, it's pretty easy. Mine is rich. Michael, I'm sure yours is Michael. Yasha is Yasha, right? And so it's like, how do you get to that one person and make it seem like this is just for them and nobody else? It's pretty. Once you get to that, once you work backwards from there, you can unlock amazing potential. And then there's one thing that's worth saying is there's this thinking that Amazon, instead of being a buying company, will eventually turn into a returns company because they'll know you so well. They'll send you stuff you didn't even know you needed. And then only so often you have to send it back, right? And so what that means, it's a silly example to say, The value we don't even know yet. It's like we're going to unlock new organizational behaviors for $2 trillion companies if we stay on this path, right? Or we'll go, there's another question, is AI unhealthy? We could go in an opposite direction too.
Cool. I think we're just out of time. If you guys are down to like give an opinion on sort of that last question, maybe we can call that the last question of the night. Does that sound good to everyone? All right.
Can I hold the mic for 2 more seconds then about being good? Right.
Yeah.
I got to say, I'm going to outsource this question to somebody we do know, right? Maybe, so everybody might know Kai-Fu Lee. He wrote this book in like 2017 called AI Superpowers, super cool book. This one just came out like last week or whatever. I'm most of the way through. It has shed light on what's going to happen in my mind over the next 20 years in terms of modern technology rooted in reality today and how it could impact everything from education to relationships and in between, not always in a good way, right? And so from a healthy perspective, the last thing I'll say is, like I mentioned at the beginning, the company I sold was in AI for social good. And one of the things I asked was, of my one client, I was saying, do we as the developers of this technology have sort of a moral imperative to do better? Because we are mimicking your workflow, but I can make changes that are improving it from a moral setting or whatever, right? This person said, no. They said, we do things the way we do them because we want to do them that way, even if they're kind of wrong. I have been uneasy about that answer from that person for 7 years now. And I'm going to stay on it. And it's uneasy until the day I probably die. So AI is only unhealthy because we're thinking this way. We're not thinking we could do better the second time around. Thank you all.
I'd just maybe chime in and add, kind of a blanket place where it goes wrong is where we fail to specify what we truly care about. We're so good. We have these really powerful models. They're amazing at optimizing the thing that we tell them to optimize, but we don't specify that right. That has another name called Goodhart's Law. I think that's where you see some of the failures on social media with recommendation systems and stuff like that. But that's frankly where you see the failures from your Amazon recommendations, and that's where we see our failures when we try to make the most performant speech to text system. So it's extremely wide ranging, and so thinking long and hard from the get-go what you care about and not trying to fix it after the fact is a good way to avoid it.
Cool. Well, does anyone have anything they would like to say on that remark as well? All right. I think we're there. This is such a fantastic conversation. Thank you guys for giving your time today for everyone. We had about 80 people, so I think a lot of people got to hear some amazing opinions on really important questions. So thank you again, and that's pretty much the end of the session. Again, we have a lot of great content coming up this week as well, a couple more software-related panels, especially tomorrow. So thank you guys again so much. This was an amazing conversation. Have a great night, everyone. Bye.
Thank you.